The malaria parasite's life cycle is very complex, involving many stages. As the mosquito feeds, malaria sporozoites enter the human bloodstream. They quickly make their way to the liver and infect the liver cells with the help of the circumsporozoid protein. The parasite develops into mature schizonts, creating tens of thousands of merozoites, which burst out of the cell and travel back to the bloodstream. They then infect healthy red blood cells, reproducing and eventually rupturing the cell, liberating more merozoites, which in turn go on to infect other cells, leading to the massive destruction of red blood cells. A few of the infected cells develop into gametocytes and can remain in the bloodstream for several days. Some of these gametocytes may be ingested by another mosquito during a subsequent feeding. Inside the mosquito, the gametocytes develop into new sporozoites. So now the human has infected the mosquito. The life cycle comes full circle and continues. Uncomplicated malaria includes symptoms like severe headaches, joint pains, jaundice, fevers, nausea, vomiting, chills, shivering, and convulsions. Severe malaria can lead to symptoms like anemia, seizures, comas, neurological problems, acute respiratory distress syndrome, cardiovascular collapse, acute kidney failure, low blood glucose, and if left untreated, death. Diagnosis of malaria is done through blood smears, using microscopes to analyze the patient's blood for blood cells infected with the malaria parasite. Clinics can also use rapid diagnostic tests, RDTs, which can detect malaria antigens in the patient's blood. However, the malaria parasite has become increasingly more resistant to some of the malaria treatments.
Is actually a parasite protein. And when we get rid of P52, then the parasite dies very early on when it goes to the liver. So if you get rid of P52 in the parasite will go to the liver, but then it'll die. So we actually have a clinical trials center on site here, and our volunteers for the clinical trial come and they put their arm on a cage of mosquitoes and they get bit by these mosquitoes. And these mosquitoes have this attenuated malaria parasite. And so the idea is that basically you give this weakened form of the malaria parasite, and that helps your immune system develop the responses that it needs in order to fight off the malaria parasite next time it sees it in the healthy version. We believe that live attenuated vaccines are the best out there. They're not the furthest along currently, but we sort of hope that they'll catch up because at least in animal models they're 100% effective. That there's this whole emphasis on global health, but yeah, it's really wonderful to hear that there are students that you're working with who are interested and engaged in the way. It's great.
Our partners in this project from St. Joseph's Secondary School in the Varia community have learned so much throughout their research. These young men and women are now determined to be advocates of malaria intervention in their community by taking adequate preventative measures, encouraging people to seek early diagnosis and treatment, and keeping updated with the newest malaria-related developments. This project has made our knowledge on malaria expansive, and we're inspired to take action.
Funds and awareness are lacking, no matter where we are in the world.